Hello everyone, welcome to my channel. Today we'll be discussing about the approach of application of differential equation and its approach to civil engineering. So without any delay, let's move to the application of differential equation. There are various enormous applications of differential equation such as population dynamics, radioactive decay, Newton law of cooling, mixtures, beam deflection. Today, mainly, we'll be discussing on beam deflection, which is the approach to civil engineering. So, without any delay, let's have some discussion. So, what are beams actually then? Beams are the members in a design that primarily resist loads aimed laterally to the beam axis. Beams are commonly used in civil engineering, but there are also members that exist like beam in mechanical engineering and are analyzed as such, wherein some cases we use differential equation to solve various computation. Beam deflects in the form of bending, as you can look in this figure. It's so what does deflection mean? Deflection is when a member deviates from its original orientation. As you can see in this figure, it is deviated like this by pressure, by tensile force P. The main reason behind beam deflection in this manner is due to their role in supporting vertical loads, wherein if not properly calculated, the tendency is to deform or sometimes it will break. So the study of beam deflection is important in the safety of a structure. Not only it is used for safety, it is also used in serviceability of the structure. A beam that seems to be bending can cause a psychological effect on the occupants. Even if the beam is structurally safe, it may cause uneasiness and discomfort in people, leading them to believe that the whole structure is not well made. In some other infrastructure, beams are used as an architectural design. So, today we'll be discussing beam deflection and we'll try to prove the elastic curve of a beam with the condition y equals to 0, dy by dx equals to 0 at x equals to 0. We have to prove this part, and given is this part. So where E is modulus of elasticity, I is moment of inertia of the cross section of beam about its neutral axis, and P is tensile force, this acting here, right here. So before we solve problem, let's have some discussion on types of beam. There are I think 3-4 types of beam. First one is supported beam. If a beam may just rest on support like a knife edge, it is called supported beam. And next one is fixed beam, and next one is cantilever. Cantilever means if one end of beam is fixed and the other end is loaded, it is called cantilever. So let's try to solve this problem. let's try to prove this problem with the help of differential equation, which is the approach to civil engineering. Okay, the given part is this, and we have to prove this equation where n equals to p by e into I. So let's start. Here the differential equation is given by ei e dot I times d square y by dx square equals to py minus 1 by 2 wx square. As equation 1, it's given already from here, and now dividing every side by e into I, we get this equation, and this is d square, capital D square, minus n square y, this means n, and equals to minus w by 2 times e into I x square, where n square equals to p by ei. Now solving further, auxiliary equation is m square minus n square equals to 0, putting d as m, so m equals to plus minus n we get. Now cf is y equals to c1 e minus nx plus c2 e nx. Now solving this, now pi is y equals to 1 by this d square minus n square times, so right side value, this is type I think 4, and by solving this d square minus 1 square minus w by 2 into I, and this goes up, then here power minus 1 times x square. Now solving this, now we have read one formula, 1 minus x power minus 1 equals to 1 plus x square plus dot 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 to infinity, and by solving this we get this, and this from here x square is multiplied with 1 and x square, and second derivative of x square is 2, and here it is constant, so n square. Now general solution is we have y equals to cf plus pi, where we have already find cf and pi, so cf is c1, this one equation, and pi is this one equation. So by using the given part where y equals to 0 at x equals to 0 in this equation, we get 0 equals to y equals to 0, so equals to c1 x 0 means e power 0 means 1, so c1 dot 1, c2 dot 1 again, and w by this part is 0, so 2 to cancel, and w by n is n power 4 times e times I. We'll let this equation be a. Now differentiating equation 2 with respect to x, we get this again. Using condition dy by dx equals to 0 when x equals to 0 in 3 means this equation, we get 0 equals to n1 c1 and n2 c2 minus n1 c1 plus n2 c2, so 0 equals to minus c1 plus c2. So c1 equals to c2. Now putting the value of c1 equals to c2 in a means this equation, this one, will get c1 equals to minus w by 2 times n square p. As we know that from here c1 equals to c2 equals to minus w by 2 n square p. Let this be c. So putting the value of c1 and c2 in equation 2, we'll get this equation. And now from here, cos hyperbolic n x plus w by 2p x square plus w by pn square. By opening this bracket, this e power minus nx plus e power nx by 2 equals to cos hyperbolic nx. So substituting this value as cos hyperbolic x, we'll get this equation, and by solving this equation we'll get the proof. So it is proved from the given. Now this was the application of differential equation in civil engineering approach, and this one is the application. And now further we'll be discussing about the problem, how to solve the problem of parabola and ellipse. So before starting, I will tell you one thing, that just have a look at this video and have a clear concept of parabola and ellipse. So for that, you have to take a pen and a piece of paper so that you can note down any doubts. Okay, let's start. So for conics, we have a general second degree equation: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 represents a pair of a straight line if this determinant equals to 0, and ellipse if a times b minus h square is greater than 0 and determinant is not equal to 0. A hyperbola if ab minus b square equals to 0 and ab minus h square, make it correct, ab minus h square equals to 0 and this determinant is not equal to 0. Two parallel line if a by h equals to h by b equals to z by f. A circle if a is equals to b is not equals to 0 and h equals to 0. A special case of ellipse. A rectangular hyperbola if ab minus h square is less than 0 and determinant is not equal to 0 and a plus b equals to 0. It's a special case of hyperbola. So to check whether it is hyperbola or straight line or ellipse or parabola, you must confirm this point by substituting the value of a, b, h and determinant as like this. So let's move on forward. So this looking triangle is a determinant of 3 times 3 order, where first row and first column represent a, h and g, a, h, g, and one diagonal represent ABC and remaining F and F. So by finding this determinant, we'll get the value of this triangle. And note, ellipse becomes circle when major axis is equals to minor axis. So let's move forward. Today we'll be mainly discussing about parabola and ellipse in this video. So before starting, let's here are some formulas. Here are some formulas of parabola. So look at this and note it down. And okay, you note it. We'll be moving forward. To find coordinates, here are also formula. So first, so let's have one question discussion. Here the question is 25x square minus 120xy plus 144y square minus 2x minus 29y plus minus 1 equals to 0. So before here we have to find axis, tangent at vertex, equation and length of lattice rectum, coordinates of vertex and focus of parabola given by equation. So at first, to solve this process, we have to check whether this equation is parabola or hyperbola or ellipse. We have to confirm it and move the forward steps. So here, by comparing this equation and by comparing this equation, we get the value of A as y, B, C and F, and by putting triangle a formula 25 by putting first row and first column as A at C and ABC as diagonal and FF as the remaining part. This is not equal to 0. I get this not equal to 0 by direct calculating on calculator. So you also do the same. And AB minus h square equals to 25 into A value is 25, B value is 144 minus 60 whole square is equal to 0. So the given equation represent parabola. So at first we have to check whether it is parabola or hyperbola or something else, and then we have to start the forward method. So the given equation is this, and first we have to make this in terms of a square, A plus B whole square, and remaining part is here, and we'll be adding lambda. We'll be adding lambda. So for here is not lambda, so for balance we have to subtract lambda here, lambda square here, and 24y lambda minus 10 lambda x, and this is from here. So from this formula we are solving this, we're getting this, and we get this after solving, and after that combining x in one side and y on other side, we get this, and after that we choose lambda such that this equation equals to 0 and this equation equals to 0, and these two equations must be perpendicular. That means the first equation slope and second equation slope multiply must be -1. So let's move forward. So after that we'll get this by solving the value we'll get this lambda as 1, and from equation 1 we get this this equation which is in standard form. And now the axis, first we have to find axis. So axis is equals to lx minus my plus n equals to 0, which is in left hand side, as 5x minus 12y plus 1 equals to 0. Let this equation be 4, and equation of tangent at vertex is given by mx plus ly plus q equals to 0, which means which is in right hand side, and here 12x plus 5y plus 2 equals to 0. So length of a lattice rectum is given by 1 by root under L square plus M square, where L is 5 and M is 12. By solving this we get a length of lattice rectum as 1 by 13. So let's move forward, and which means lattice rectum means 4a, so 4 equals to 1 by 13 and a equals to 1 by 4 times 13. So equation of lattice rectum is given by x equals to a. So x equals to a, and x value will get as this from previous page, and a means here, and by solving this we'll get equation of lattice rectum. Let this equation be 6. So for coordinate of vertex, solve axis and tangent equation. That is, axis means equation 4 and 5. By solving that two equation we'll get here, we'll get this point of vertex, and for coordinate of focus we'll be solving equation of axis and equation of lattice rectum. Equation of axis is on previous page, and equation of lattice rectum, by solving this two equation in calculator we'll get the points minus 2 by 13 comma 1 by 52, which is the coordinate of focus. So let's move forward. Now let's come to an ellipse. So ellipse is also same as parabola. For comparison, just we have to know that AB minus h square is greater than 0, and this determinant value must not be equal to 0. So the process of solving ellipse is, for center we have to differentiate a given equation partially with respect to x and y respectively, and by solving that two equation we'll get the value of points of center as alpha and beta. So for equation refer to center, shift the origin to alpha and beta, that is x equals to capital X plus alpha and y equals to capital Y plus beta. So new equation will be a x capital X square plus 2h xy plus by square is equals to this determinant value by h square minus ab. So by dividing this one on both sides, we'll get a new equation which is referred to center. Now we have to find the length of axis. Compare new equation as ax is 4 plus 2xy plus by square equals to 1, and use this formula, and by solving this formula on calculator will find we can find the axis, length of axis, which means bigger r will be semi-major axis and small r will be semi-minor axis, which is denoted by r2, r1 and r2 respectively. And for eccentricity we have to find r square, small value of r square equals to r1 whole square times 1 minus eccentricity square. By knowing these two value we can easily find eccentricity. So for lattice rectum we have 2r2 square by r1. So let's move forward. For Fourier and directrix, it's so simple. Write the equation of major axis and find the slope of major axis and put m equals to tan theta, what you got as m, and by using Pythagoras theorem find the value of pb and h and put that value in sin theta and cos theta. And for Fourier the formula is here: alpha plus minus er1 cos theta comma beta plus minus eccentricity r1 sin theta. So equation of directrix will be given by this equation by substituting the value of alpha, beta, cos theta, sin theta, r1 and e. You can easily find the equation of directrix. So let's move forward. And for equation of axis also use this formula. As for major axis you'll use this formula, and for minor axis you'll use this formula. And at last don't forget to change capital X in terms of small x. So let's solve one problem. Here is one question that so that the equation this represents ellipse. Also find center. Equation referred to the center, equation of axis and length of axis, eccentricity, length of lattice rectum, foci, directrix. Given equation. So here is the given equation, and this comparing with this equation will get the value of what we need, f, c, a, b, z, and by finding the determinant we will get this value as minus 9,000, which is not equal to 0, and ab minus h square, which is greater than 0. So this conic represents ellipse. And for center equation referred to center, foci, length of lattice rectum, directrix. Okay, move on. We should use that formula previously I said. For center, given equation this, first we have to differentiate this partially with respect to x, we find this equation, and also partially with respect to y we find this equation. Solving 1 and 2, solving these two equations, we get center represent alpha and beta. So equation refer to center. Shifting this origin to 2 comma 3, we have small x equals to capital X plus 2, y equals to y plus 3. Equation will be this. Substituting this value here, 0 is missing. Okay, put that 0 1 extra, and let's move on, and we get this equation. So this equation is the new equation in which center is shifted, center and origin is shifted. Now for length of lattice section, for length of axis we should compare this equation, new equation, as 1 equals to 1 ax square plus 2hxy plus by square equals to 1. We find the value of a to a b, and previously I said this equation, this formula to find the value of axis, length of axis, and from here we get two values of r, 4 and 2 and root 6, and so root 6 is greater than 2, so length of major axis, not length of semi-major axis, will be root 6, and semi minor axis will be 2. And here so equation of axis will be major axis. Here formula I have recently shared you by putting E as 7/3 from previous equation, and R1 as 6, R1 as root 6, so root 6 square will be 6, and this equation will get this equation, which is the equation of major axis. And by putting this in this equation, R2 in this equation, we'll get another equation of axis. So for eccentricity, we'll be finding R1 and R2 as we get previously R1 and R2. So putting this value in this formula, we'll get eccentricity value as 1 by root 3. And for lattice rectum, length of lattice rectum will be using this formula, and by putting this R1 and R2 value in this formula, we'll get 4 root 2 by 3. So for foci and directrix, major axis is 2x minus y equals to 1, and here is and foci and directrix, we have to use major axis and find slope and use the tan theta, and by using tan theta, p by b, and using Pythagoras theorem, we'll get h as root 5. So sin theta equals to p by h equals to 2 by root 5, cos theta equals to b by h equals to 1 by root 5. And so by putting this formula, we'll get, by solving this, we'll get this foci coordinate, and equation of directrix is given by this, by substituting the value of alpha, cos theta, beta, sin theta, r1 and e, will get this equation. So conics is a bit simple. If you understand the technique, you'll get easily you can solve the problem, and easily you can get your answer. So it's only the fact that you'll be practicing in a paper, and by knowing concept, then only you'll feel the math as easy subject. So this much for today, and hope you guys enjoyed it, hope you guys like it. So thank you. For next part will be furthermore, I'll make another video for next part.